So the main idea in my mind of what Algebra 1 is, it's learning tools that help us solve for an unknown variable. Like if I write 3x is equal to 12, the goal of the Algebra 1 is to say, hey, what is x going to be to make it 12? And oftentimes, like, what is this? And in Algebra 1, our goal is to find the definitive answer. And sometimes it may be more than one answer, but what is the definitive answer that x could be? What could x be to solve this problem? And in Algebra 1, like we learned this idea of there are techniques, there are rules, there are steps, and these actually apply to your regular day life. Like imagine if your mom says, here's $12 and I need you to go buy some stuff at the grocery market. If each item costs $3, how many items can you buy? If you only have so much money to spend, how much can you allocate on each of these items? If you're going to throw a party and your mom says, here's $200, what do you want to do with this money? Some of you guys are going to have a quince, and maybe not this year, but next year. But your parents have saved up a lot of money to figure out how much they want to spend on the dress, how much they want to spend on the party, how much do they want to spend on all the little cute uniforms everyone wears, right? The photographer, the flowers, all that stuff has to be calculated. And in a sense, that is algebra. It's the same idea of the logic there. So we're going to talk about the techniques and our basic 4 techniques that we've covered in pretty much any junior high math. So the first one is, if I say the opposite operations, let's talk about this. The opposite operations. Oops, that was terrible. Operations. This is also known as an inverse operation. Now, an inverse is another way of just saying undo, the opposite operation. Inverses undo things. Does everything in the world have an inverse? Like, does cooking ever really have inverses? If I mix items like strawberries and bananas and orange juice into a blender and I stir it up, is there any way to undo that? No. Like, good luck. Imagine if you take 2 bottles of sand of different colors and mix them together. Is there any way that you could individually separate out the colors again? You know what? It would take you a long time. It is possible. And in math, that's the idea. Sometimes it is not possible, and sometimes it is possible with a lot of work, but we are learning the tools to do so. So let's talk about the opposite operations. The opposite operation of plus is minus. The opposite operation of minus is plus. So the idea is these undo each other. An example of this is if I have a positive 3, well, if I minus a 3 to it, we end up with 0. They essentially cancel each other out. If I have a negative 3 and I add 3 to it, they essentially cancel each other out. If we start off, let me write this on the left. If you had $12, you had $12. And if I added $5 to it, hey, you have $17 now. Nice. But what if I had to say, oh man, I made a mistake. I gave you too much money. Can you give it back? The opposite operation of a plus $5 is a minus $5. And we're back to our original $12. So the opposite of plus is minus. The opposite of minus is plus. Our next fancy one is multiplication. So multiplication and our opposite operation of multiplication is division. And we can see this in not getting to 0, but if I look at this, 3x, if I'm multiplying by 3, we undo it by dividing by 3. And this gives us our original value, x. If I give you guys division, the opposite operation of division is multiplication. If I wrote x over 5, the opposite of a divide by 5 is a multiply by 5. So if I multiply by 5, we still end up dividing the 5s, leaving me an invisible 1. And instead of writing that 1, we'll just write x, leaving me my original number. Using numbers for this example, if you have the original number, let's say 6, that's my original number, and I multiplied by 3, that takes me to the number 18. Oh no, I made a mistake. I shouldn't have multiplied by 3. The opposite of operation of multiplying by 3 is dividing by 3. And that takes us back to our original 6. So to get out the basics, the opposite operations always undo a process that we're trying to get rid of, okay? So let's give ourselves our problem originally. We said 3x is equal to 12, and I saw someone already wrote the answer 4. Thank you very much. We could solve this in actually a couple different ways, and in math, it's really up to you, whichever method works for you the best, but I would like you guys to not close your mind off to new methods, because these new methods are, I would say, more practical than some of the early methods that you learned in elementary school. So one thing we could do is we could just start guessing. You could just guess. We can guess x is 1, x is 2, oops, x is 2, x is 3, and x is 4. And that's how, a lot of us do this. We just guess really quickly though. We're like, okay, 3 times 3 is 9, darn it. Oops, I made a mistake here. I wrote this wrong. I don't know why I wrote this. I think I wrote the answer. Sorry, you'll see me write the answer sometimes because my brain has been trained to always jump to the answer as fast as I can. It's a reactionary thing.
I think I know the answer, Mr. Ko.
Yeah, I think a lot of people do. I'm talking about the process. Okay, the process. I don't think brute forcing your way through is, you know what, you're right. Brute forcing your way through a lot of things is never good. Think about hacking. Okay, don't think about hacking. But there's a lot of things that you don't want to brute force your way into it. But is it a wrong way? Like, would I not get the answer? So if I plug in the 1, this would be 3 times 1 is not 12. Whoops. I should write not 12. 3 times 2 is not 12. 3 times 3 is not 12. Oh, 3 times 4. Oh, this is 12. Yay, x is equal to 4. Now, you could do this for a lot of different types of problems, honestly. You could throw this onto a graph, such as Desmos, and then Desmos, you could start guessing the answer. And in algebra, there is an idea of estimating. And you know what? Estimating takes no time at all. You guys could guess a number and then verify it. But to get the right answer, it takes a lot more work. So we're going to talk about our opposite operation and the idea of algebra. Here is the idea of algebra. I want to get x alone. The goal is to get x alone. Literally, the statement is x by itself. Lonely, lonely x. X is by itself. And it is by itself on one side of the equation. We want to also understand what this symbol means. This guy is equals. Darn it. Equals. And that means the left side is balanced with the right side, that the two sides are equally weighted. If the right side is 12, the left side has to also be 12. So we're going to go through a process called opposite operations, and we're going to divide both sides here by 3. And here's the process that's going on in my brain. First, you want to, 1, identify what's the variable. Identify what's the variable. 2, you want to decide what numbers do I have to get rid of from that side so that x can be alone. Step 2, I want to get rid of the 3. So again, step one, you always want to figure out what your variable is. It might seem silly, but really, x is what I'm solving for. 2, start categorizing what numbers I want to get rid of. The reason why is if you don't do this, some people actually start thinking you have to get rid of the 12. And that is not the case. So spend some time thinking, what numbers do I have to get rid of so that x is by itself? And in this case, I want to get rid of the 3. The next process is saying, okay, how do I get rid of that 3? Well, what's going on with 3? 3 is adding, subtracting, multiplying, or dividing. 3 is when we multiply, there are a couple ways of writing multiplication. Again, we're kind of reviewing at the same time. You can, when we're multiplying, you can write it as 3 times x. But this is super confusing, because why do we have xx there? We can write 3 parentheses x. Or we can write parentheses 3 parentheses x. We can write parentheses 3 and leave the x alone. And all these are the same way of writing it. We can also write 3 dot x. And the last way, we can just write 3x. So one big thing we have to realize is that there's so many different ways in math of writing the same thing, and we have to be comfortable with it. And please be aware that we've seen all these different ways, but the whole goal is to show that numbers, when they're next to each other, it's a multiplication problem. If you don't see a addition or subtraction, it is automatically going to be multiplied. And the opposite operation, the inverse operation to multiplying by 3 is dividing by 3. Now, when we did this, the 3 is divided out. So in your head, what's 3 divided by 3? In your head? If you said 0, it's a very common mistake. Remember, 3 goes into 3 exactly 1 time. So it's going to be 1 for us. So it's x is equal to 4 divided by 3. Sorry, 12 divided by 3 is 4. Now, do I have to write an invisible 1 here? No, it doesn't help us at all. So all your teachers have taught you guys not to write the 1. All right, x is equal to 4. Let's do this one more time as a practice. 5x is equal to, let's do 10. Something easy just to work out the idea. First step, identify what your variable is. Identify what your variable is. Step 2, identify what number you want to get rid of so that x is by itself. In our previous problem, we solved x is 4. That was our goal. Remember, this was our whole big goal idea, get x by itself. And we did get x by itself because we asked 3 to leave. In this same problem here, what number do you want to get rid of? Who do you want to ask to leave? I'm seeing the 5. So first step, identify your variable. Second step, identify what number you have to get rid of. What is the 5 doing to the x? It is multiplying. So the opposite of multiply is we are going to divide by 5 to both sides, because opposite of multiply is divide. 5 divided by 5 cancels out, giving us a 1. Some teachers don't like you saying cancel. That's fine. Equals to 2. Now, after we've solved our problem, after we got x alone, see, x has to be 2. The whole goal is to say, what is x? X is 2. I want you guys to make sure you double check. And it could be mental math, but you want to make sure this answer is true. If I plug in, x is now 2. And I write that as a parentheses, because if I just wrote 5, 2, it looks like 52. The parentheses reminds me that I'm plugging in a number, okay? A parentheses reminds me I'm plugging in a value, and that's 10 is equal to 10. Check, that works. We have found the number that made them equivalent. Now to work through our other processes, we have addition, subtraction, multiplication, and addition, subtraction, multiplication, and division. Yeah. Okay, let's use our next example. Let's go back to our basics. So x plus 3 is equal to 8. Now, when I was a kid in algebra, not even algebra, when I was in 6th grade, I remember the first time I saw an x, and my teacher asked, Edward, what is the answer? She singled me out, first time I've ever saw an x in my life, and she asked me, what is x? What is x going to be? And then I was like, I don't know what x is. I've never seen x before in my life. And well, not in my life. I knew it was a letter, but I never saw letters in a math problem. So she gave me a comment and she said, Edward, it could be anything you want it to be. And I said, fine. X is 8. X is 9. X is 10. X is A, B, C, D, E, F, G, H, I, J, K, L, M. Oh, X is like 20 something. And she, of course, told me I'm stupid and I'm wrong. Okay, she didn't use the word stupid, but the way she looked at me implied that I was stupid. But what happens is she wasn't being clear about what X really is. X is not anything you want it to be. That's actually a lie. Yes, it's a variable and it can change, but X can only be whatever fits the situation. X could not be 3. X could not be 4. X could not be 20. X here has to be 5 because 5 is the only number that would make this equal to 8. And that's a misconception sometimes we think that X can be any number you want. No, if this is an equal sign and this is an equation, X can only be the value that makes this a true statement. So we're going to go ahead and solve this problem now. And I didn't know how to solve this before. The teacher wanted us to do guess and check. So they want us to guess a number. So let's go through the process in which algebra tells us. Step 1, identify the variable. That is the variable X. I want you to be alone. How many guys during COVID time, during this pandemic time, have wished you could be alone just for a little bit, right? Yeah, right? Like it's a thing. And I had a trick when I was a kid. When my mom would come in my room, and all parents have this trick. You have to find out what works for your parents. And I wanted to be alone. I wanted X to be alone, and I'm X. I'm the variable. To get my mom out of the room, I would say, Mom, can you make me something to eat? And my mom was like, sure, let me go fry you some eggs. Let me go make you some bagged ramen. Do you want me to go out and buy you something to eat? Even better. My mom was the type of mom that would show up at like 11 o'clock at night with like a pastrami sandwich and say, eat this. I'm like, I gotta go sleep. Eat it. I'm like, oh darn, I hate my life. I'm eating a pastrami sandwich at 11 o'clock at night with French fries. Where's the milkshake, Mom? Did you forget the milkshake? So first step is to 1, identify the problem. 2, think about how to get your parents out of the room. Don't say that. Think about the opposite operation that would clear out the numbers. So I'm trying to get out the 3. So the opposite operation of +1 is a -1. Sorry, the opposite operation of +3 is a -3. So I'm writing -3 to both sides. Now, one thing that we want to talk about is how can you just write random numbers everywhere? Why don't you write the -3 on top? Why don't you write the -3 in the front, right? Why are you writing it on the bottom? And it's actually one reason is that your teacher told you so. That's the only reason. The actual math way of writing this is this. If I'm balancing out an equation and I write x plus 3 is equal to 8, and look, I included some space here. The actual math way is to write -3 on both sides, like that. An equal sign means they are both equal to each other. So if I do something to one side, as long as I do it to the other, this is totally legit. Your parents have told you, if you guys have siblings, I love you all equally. My little mijos and mijas, I love you both equally. I'm a twin. I have an identical brother that looks just like me. Okay, he's taller, he's handsomer, and he's richer than me, but we're the same, okay? We're equal. And my mom has always told us, I love you guys equally. But who gets all the toys? He does. Okay? There is no equal sign in my family. And you know what? You probably feel that way in your family too. I mean, we all have favorites. Even amongst your friends. You say, I love my friends. I love them all equally. No, you have your favorites. Let's not lie to ourselves. Let's be honest here. Not true, yeah. Okay, so if you look at here, the actual math way on the right side is to actually write a -3 to both sides. But your math teachers, no, you do not want to write the problem over again. You don't want to write the problem over again. So they thought, here is the easiest way, a compromise for both of us. We understand that when I write -3 to both sides, I'm really doing it this way. It's almost like it's a crutch. It's like I'm really squeezing it into this corner here. Okay, so I want us to have the understanding. We're really doing this on the right. I'm actually adding it to both sides. But to make life easier on everyone, I'm just going to write it on the bottom. But to be fair, I am writing it on the left and right side of the equal sign. I'm being fair. This is a common mistake for a lot of people who are confused about what's going on. They write this, Mr. Ko, I'm -3 to both sides. You know you -3 twice to the same side? And some of your parents are like that too, guys. Like, they pick on one kid and they keep saying, you wash the dishes, you wash the dishes. I washed the dishes yesterday, wash the dishes again. Oh, man. Sorry, I shouldn't be calling your parents out. But please be aware, this equal sign is like a divide here. There is a wall of equalness. The left side must equal to the right. You must write it on both sides. All operations have to happen on both sides. Stop it with this cancel culture, cancel parents. Gosh. I'll tell you another story about my poor childhood a little bit later. That's not when this isn't recorded. Okay, so the left side is -3, the right side is -3. So we realize the 3's cancel out because this was my inverse operation. I chose a correct one, and x is by itself. Different color. X is now by itself. Because the 3 -3 canceled out, on the right side, we're dealing with that. The consequence, 8 -3 is 5. Do double check. Double check. X is 5. So 5 plus 3 equals 8. That is a confirm. Okay, so let's go through the other operations. We did multiplication and addition. Let's do subtraction. X minus 5 is equal to 12. Now, I can imagine people saying 7. 7 minus 5 is 12. Well, 7 plus 5 is 12, right? But sometimes when we rush to an answer, you know, many of you guys might have caught yourself and you said, oh, wait, no, that's subtraction. And that's perfectly fine. There is a carpenter's saying, measure twice, cut once. When you're doing construction, before you cut the wood, before you break something that you cannot change, the trick is this: always measure twice. Measure twice to verify, and then cut once. Then you can go ahead and cut. Same thing happens when it comes to your answers. Verify twice, and then give your answer. Okay, so for step number 1, let's talk about steps. Step number 1, identify the variable. Which of these are my variable? The x, the 5, the 12. The x is my variable. I want to solve x equals 2. I want x to be alone. That's the goal. Step 2, what number do I have to get rid of to get x alone in his own room? This is his room. He wants to be alone. Please, everyone, just leave me alone. 5 needs to get the hell out. 5 is subtracting. The opposite of a -5 is a +5. So we're going to use our opposite operations here. I'm going to +5 to both sides. If you would like to be the kid who likes to write out the operations to both sides, that's fine. Be that kid. Be that person. And you can write out this way. And that's 100% okay. This is just another way of looking at it. But I feel like it's easier for all of us to stick with this standard that we've been working with. the x, so the 5's simplify out. So -5 plus 5 is 0. Do you guys want to spend time writing this? No, right? Nobody wants to spend time doing that. So with your previous teachers and me, we all just say, you know what? 5 minus 5, gone. Don't even write it anymore. Save yourself time. Okay? And it's an understanding that we have that the 0 doesn't need to be written. Anything plus 0 doesn't have to be written. Okay? And 17, verify. 17 minus 5 is equal to 12. And that is true. That's a true statement. Let's do one more. Let's talk about the fractions. Whoosh, fractions. So we want to say 6, sorry, not 6, x divided by 6. X divided by 6 is equal to 18. Oh, not 18, I'm sorry. That'd be crazy. Equals to 4. X divided by 6 is equal to 4. Now, we're going to go through all our steps. Most of you guys, maybe some of you guys, maybe 2 of you guys know the answer, but our goal is to follow the steps that we've been practicing to make sure our brain starts to get used to these steps. So step 1, find the variable. What's the variable going to be? Identify it. It's going to be x. Step 2, what number do you want to get rid of? I want to get rid of the 6. Now, what is 6 doing to x? Adding, subtracting, multiplying, or dividing? Since it is written as a fraction, it is dividing. So the opposite operation of dividing is multiplication. Now, I don't want to write times 6 down here. That actually becomes really confusing. So we don't write it that way. I'm going to write it next to it. I'm going to write a parentheses here and write a 6 here to both sides. Now, you could write it in the back if you have space. You can write it in the front if you don't have space. If I write it this way and I write a 6 in the front, that is totally okay. That would still be 100% correct. And the reason why it doesn't matter for multiplication if you write in the front or the back, here's a simple example. 2 times 3 or 3 times 2. Does the order matter in multiplication? 2 times 3 or 3 times 2? The order doesn't. They're both 6. But some operations, it does matter. 2 minus 3 or 3 minus 2. Order super matters when it comes to subtraction. So these are not the same. But when it comes to multiplication, it doesn't matter which one you write in the front. So let's go ahead and look at this. What happens to 6 on top and 6 on the bottom? They divide out to become what number? An invisible 1. So I'm not going to write it. So we're left with x is equal to 6 times 4 is 24. If I went to the right side, these would still divide out. And we still end up with 24. Now, the goal of our solving in algebra is to get x by itself. And look, x is by itself. X is on one side and the number is on the other. Let's double check. 24 divided by 6 because x is now 24. This is called substitution. We're substituting the x for 24. And this does become 4. And that is correct. Okay, so your homework today really is just working on these 4 basic operations. Again, your homework is working on these 4 basic operations. The homework is posted. It is going to be page, let me look it up again. I think it's page 8. Actually, you know what? Let me check if it's posted yet. Homework 1 is posted and it's page 8, problems 5 through 14, all, and 21 through 30, all.